Hello everyone. In this video, we are going to solve word problems on geometric sequence, and this is the second part. Before we go over this example right here, let's have a review on the important formulas that we need to use in solving problems involving geometric sequence and geometric series. We remember that the nth term of a geometric sequence is represented in an equation. T of n is equal to a sub 1 times r raised to the power n minus 1, or this t of n can also be represented as a sub n. So other textbook are using t of n, others are using a sub n. They're pretty much the same thing. They're just variables. It can also be again represented as a sub 1 times r raised to the power n minus 1. We remember that our t of n and the a sub n represents the nth term of the sequence, while our a sub 1 is the first term of the sequence, and our r is the common ratio. The second formula will be used to determine the sum of the first n terms of geometric series. This is represented as s sub n is equal to a sub 1 parentheses 1 minus r raised to the power n over 1 minus r, where our s sub n represents the sum of the first n terms, a sub 1 represents the first term, r represents the common ratio, and n represents the number of terms. Okay, so we go over the problem here. The table below shows population estimates for California from 2014 through 2017 from the U.S. Census Bureau. So we have here the year 2014, 15, 16, 2017, and this is the population in California in millions. So on 2014, that's 38.59, 2015, 38.90, 2016 is 39.14, 2017 is 39.34. Again, these are in millions. The first problem that we have here is we are supposed to show that California has a population increase that is approximately geometric. We are supposed to round our answers in 2 decimal places. So what are we going to do in this problem right here is we're supposed to solve for the common ratio. Again, the common ratio is represented as letter R. So I'm just going to go ahead and write that up here. So R is equal to, in order to determine the R, we're going to divide these two numbers right here. So I'm going to start with the second divided by the first. So that is 38.90. I divide that by 38.59. If we use calculator on this, we can get a value, and it has to be rounded off to 2 decimal places. So that is 1.01. So that is the common ratio for these first two. And then we're going to repeat the same process. This time around, we will divide this value divided by this, and then we're going to divide this value divided by this. So that is one way to show that the population increase was approximately geometric. Okay, as you can see here, the common ratio is 1.01. So approximately each of these will be multiplied by 1.01. Although if you are going to multiply this by 1.01, it doesn't really come out like exactly the value, because again, we are approximating it. We are rounding it off to 2 decimal places. So the R for this is approximately 1.01. So the common ratio here is 1.01. We can therefore say that the population of California is increasing in approximately geometric pattern. Now let's move on to the next questions that we have right here. Write the general term of geometric sequence modeling California's population in millions n years after 2013. So we remember that the formula for the nth term of any geometric sequence is represented as a sub n is equal to a sub 1 times r raised to the power n minus 1. So for this problem that we have right here, we can go ahead and say that our a sub 1 is 38.59 million, and our r, we solved it in the first slide, it is 1.01. So we can go ahead and plug it in. So the general term for this geometric sequence that we have here is a sub n is equal to, again, our first term is 38.59. So that's 38.59 parentheses. Our r is 1.01. We have shown that in the previous slide. That is raised to the power n minus 1. So this is the general term that works for this geometric sequence that we have up here. Now, again, notice that this is approximate formula because, again, we are actually rounding this off to 2 decimal places. Now, the next question that we have right here is we're supposed to use the model that we have created. It's this one right here to project the California's population in millions for the year 2025. So we are supposed to round it off to 2 decimal places. So we remember that this is 2017. We wanted 2025. So we can go ahead and write the rest of the years here. Okay, now we also remember that this is our a sub 1 or the first term. So we can go ahead and label this as our a sub 1, which is 38.59 million. This means that this is the second term, third term, fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. So this means that this is a sub 12, or the population in 2025 is actually the 12th term in this geometric sequence. So then we can go ahead and solve for a sub 12 by using this model that we have right here. So we can go ahead and write this as a sub 12. So I pick the n value as 12 now because that, again, 2025 is the 12th term, is equal to 38.59 times 1.01 raised to the power. Our n now is 12, and then that is a minus 1. So a sub 12, or the 12th term, would be 38.59 times 1.01 to the power 11, because you have 12 minus 1. When we do the math for this, this would come out a sub 12, or the 12th term, is 43.05. This means that the population of California in 2025 is 43.05 million. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!